So AWS, as we know, is a collection of more than 150 plus services. They are in precise, or between precise, they are 157 services currently offered by AWS. And Amazon is one of the leading, well, Amazon has been and still it is the leading cloud computing platform, having services among among different categories. Like it offers services for computation, networking, databases, IoT, blockchain, artificial intelligence, for AR, VR, for networking, for databases. So there are multiple services offered for different categories, and these all are well managed and and they are well architected as well as compared to other cloud computing platforms, right? And there are multiple reasons why AWS has been popular. For example, AWS, as we know, first of all, it's the most popular platform. It has multiple advantages. That means it offers the model as pay as you go model. That means here we have to pay only for the services that we have used and only for the time period we have been using it. And that's why it becomes much easier for any new beginners to make sure they are not paying anything upfront, and then they have to pay only for the resources they have used, nothing less, nothing more. That exactly is what the advantage is offered by AWS to these different cloud computing vendors out there. All right. And some of the most popular use cases are like we had 21st Century Fox. So we know that this is one of the leading media houses here, leading production company, right? And again, 21st Media Century Fox makes sure that again their content is being consumed by millions of users, right? And they stream millions of hours of digital content to consumers via web, mobile, and setup devices. And that's why it uses something called as container-based service. Like we have a Docker-based services are running on AWS, and you build and they deliver the Fox now. And these all services, they are executed in Docker. So Docker is one of the leading containerization service available as a part of DevOps. And then it is integrated by with the service called as ECS, Elastic Container Service, offered by AWS, so that the entire deployment can be done within the utmost manner with the utmost efficiency as possible. Again, and they are one of the biggest use cases, one of the main, we can say, main clientele for AWS. Then followed by, then we have one of the other clientele is like we have McDonald's. So McDonald's has been the world's largest restaurant company, having its presence in more than 37,000 locations. And again, that's why they generate 64 million, they serve 64 million people per day, right? Currently, we know that the entire world is closed right now. But again, they have been serving 64 million per day on a per day basis, right? And using AWS, McDonald's, they simply built a complete system, and using McDonald's now, using the entire AWS platform, using McDonald's, they're using the entire platform here. They have been using the entire services for AWS. They have been building a system through which they can use the microservices, through which they can build the entire platform using multiple microservices. Like we have ECS, ECR, again ELB, Amazon SQS, Amazon RDS, and S3. They all have been available. They all have been available as a part of McDonald's services. So again, we have developed the entire architecture where we have been using these components in making sure the entire efficiency of the applications being deployed have been improvised. McDonald's can easily take in 20,000 orders on a per second basis with less than 100 millisecond latency, all running on top of AWS platforms. Now, let's understand the entire architecture for AWS first. So AWS architecture is again divided into multiple categories. Like we have regions and then we have availability zones. So regions are basically focused on multiple parameters. For example, to understand this in simple layman terms, Let's go back to our notepad. Let's go back to our drawing mode. And to understand this entire scenario here, for example, here we have the entire globe, right? And now here we had deployed one data center. For the entire globe, we had deployed one data center. And suppose this data center is in Mumbai. Now, if we have users coming from North Virginia, if we have users coming from Tokyo, we have users coming from London, we have users coming from Singapore and from Sydney as well, right? And from Johannesburg. So if we have multiple users coming from all around the globe, then now they if we have only have one data center available, then if we have millions of requests being generated on or we can say on a per second basis, and all the requests are being handled by a single data center, then this is bound to create a situation called as a bottleneck situation, where the entire performance, where the entire load is being generated on a per second basis, and the all the requests are being handled by a single data center. So this is bound to create a situation called as a bottleneck situation, where the entire performance, where the entire load is being generated on a per second basis, and the all the requests are being handled by a single data center. So this is bound to create a situation called as a bottleneck situation. And that's why AWS has been divided into the architecture for multiple regions. So they have multiple regions on AWS. And that's why AWS has been divided into the architecture for multiple regions. That's why just to solve this bottleneck situation, what has been done? Here we have deployed multiple micros. We can say we have divided the entire solution into multiple micro regions. So for example, here we have solutions being deployed in different regions. So instead of managing a single database, we can, or we can say data center, here we can deploy solutions in multiple regions altogether, right? So suppose if the users are coming from anywhere from North America, instead of sending the request to Mumbai, they can get a faster response by getting connected to a server has been deployed in a region closer to them. Correct? Same way, here we can deploy multiple solutions in a region which is closer to them, so that the entire efficiency of the entire application can be improvised, right? And that's why AWS has been divided into the architecture for multiple regions. So there are more than 22 regions all available all around the globe itself. Correct? All right, so now if you all want, let's explain this entire diagram once again all together. Let's erase this up. So for example, we have the entire globe, right? And if we have a single data center, if we have a single data center deployed in just one location, for example, if we have a single data center in Mumbai, right? And now if we have users who are coming from North Virginia, we have users who are coming in from, suppose, from Johannesburg, we have users who are coming in from London, we have users who are coming in from Tokyo, we have users coming in from Singapore as well and from Sydney. So if suppose if we have users coming from all parts of the globe, then if they all have only a centralized, okay, if we have the application deployed in just one center location, then if we are getting millions of requests on a per second basis, if all the different users they all are getting connected to a single data center, and if we are getting millions of requests on a per second basis, then that will create a situation of bottleneck. That means the entire application, the single data center will be receiving a good amount of traffic, and there'll be a too much load on this entire single data center, correct? And it will also increase, and that's why the chances of failure of this instance will be much higher. And the instance again, and the entire even though the system does not fail, then the chances of fail, or we can say there are latency, that means the response time will be much higher for every instance or for every request being served here, right? So just to solve this issue of failover chances and increase latency, what we can do, we can maintain multiple regions, we can maintain different regions here, right? So we can deploy a copy of our application in this region. We can deploy a copy of application in a region closer to each and every user, so that the user, instead of coming down to a central location, they can get served by by the application copy or data copy stored in a region closer to them. For example, if a user is trying to connect from North Virginia, right? So instead of the entire connection be served from North Virginia to Mumbai, if we had deployed an application to in the North Virginia region altogether, then this request can be served by this user getting connected to this North Virginia region. And suppose if anyone is coming from Mexico as well, then for Mexico, getting connected or getting served from this region will be much more faster as compared to getting served via Mumbai region, right? Same way for any user who is they can say nearby to these regions, they will be getting served by the application copy served by near to them. And that's why we have multiple regions spread all around the globe for making sure that we have a better architecture put in place. Correct? And obviously that will increase the cost. Obviously, when we are maintaining copies in different regions, that will definitely increase the cost, but that will make sure that the entire application is highly available, right? And that exactly is what we have concept as a part of regions. And each and every region, as you can see here, each and every region, they also have multiple zones. As you can see here, each and every region, they have multiple zones inside it. Like we have multiple availability zones. So that if a you suppose if a user is trying to access the application here, and for any reason, suppose if this zone is not available, and if this one is also not available, then still the user can be served via the copy stored in the other zones, right? That is exactly why we have multiple zones available in different regions. And that's why the entire architecture for AWS has been divided in multiple regions and multiple zones altogether. Yes, Sahil, we can understand